The moon. Our moon is Earth's only natural satellite. And what we mean by satellite, that's any object that revolves around another object. That could be a planet, or that could be a planet-like object. The moon formed 4.5 billion years ago. And the most widely accepted theory is that the Earth collided with a large object, something the size of Mars, maybe it was Mars, during the formation of the solar system. That process ejected materials from Earth, and that ejecta coalesced to form the moon. Now, we've got a lot of evidence to support that theory when we visited the moon in our first Apollo missions. Whenever the astronauts brought back rocks from the moon, they were analyzed, and they were analyzed using a process called radioactive dating, and that revealed that the moon and the Earth are about the same age, which would make sense because everything in the solar system is about the same age. Even more important, the rocks on the moon match rocks from the Earth, showing a very similar inner core or inner system that forms rocks. So that's the theory that explains the formation of the moon. Some other moon facts: it's about 200,000 miles away from Earth, give or take, and it's about 2,000 kilometers across. That sets it about 1/4 of the size of Earth. So it's about 27% the size of Earth, much smaller. You could fit 4 moons in the Earth if you could do that. And some other important facts are listed in your reference table. Notice how the moon occupies the lowest row here. That's all just about the moon. We're going to expand on some of these things in the next few parts of this video. I just also will reference some of the most commonly held misconceptions about the moon. So here's our first misconception. The moon does not make its own light. It's merely a reflector of sunlight. Just like anything out in space, and we'll look at this in a moment, it just takes sunlight and shoots it back towards Earth. The moon can be seen during the day. The moon doesn't rise and set based on the sun. So in other words, when the sun sets, that's not when the moon will rise. It follows its own schedule. The moon will always be visible during the day, if it's not cloudy, if you're within a week of a full moon. And then it will be visible after a full moon in the morning. So there are definitely day times associated with the moon being present. A blue moon. A blue moon is actually referring to an extra full moon that occurs within a month. It has nothing to do with the color of the moon. It's because a typical year will allow 12 full moons. But because our yearly cycle is not perfectly equal to 365 days, we may sometimes wind up with an extra revolution of the moon going around the Earth, and that gives us a 13th full moon. That 13th full moon is what a blue moon is. Sometimes the moon looks enormous, but sometimes it looks really small. And this is really just an optical illusion. If you see the moon high in the sky, it's going to look small. If you see the moon close to the horizon, it's going to look bigger, especially if it has things in front of it, like clouds, or you can see it with trees kind of in front of it, behind trees. It's always going to look bigger in those situations because you're comparing it to something that you know the size of. That's not to say that the moon doesn't change its size. There are 2 times in the moon's orbit where it's closer to the Earth and further away. Perigee is when it's technically bigger, and apogee is when it's technically smaller. And remember, that's apparent diameter. It just looks that way because of the orbit. So it's not a perfect circular orbit. It's got a slight elliptical value to it. So as a result, we do see a bigger full moon and a smaller full moon during different times in its path. Speaking of bigger full moons, there is a time when the perigee moon is closer than it normally is. A perigee full moon is called a supermoon, and then we'll refer to that as the supermoon, and that just means that it's the biggest apparent diameter measured during that year. Referencing something that I said before, everything in space is illuminated by the sun. So here's a good example of how the Earth looks like the moon when viewed from the surface of the moon. This is a famous picture called Earthrise. It was photographed from the surface of the moon by astronauts. And because the Earth is in a position facing the sun, we only see the illuminated part of the Earth that's facing the sun. That's the same process that creates phases when we're on Earth viewing the moon. The moon does have gravity. It actually has 1/4 the amount of gravity that Earth has. This is what causes astronauts to be able to jump very high. And even though the gravity is weaker on the surface of the moon, it still exerts a strong force on the Earth. So the gravity created by the moon, even though it's weak, it still pulls on the water that's on Earth, creating tides. Now, the moon structure, we are not 100% certain on because we've not been on the moon long enough to study the depths of the moon. But we can imagine that because the moon has a lot of the similar minerals that Earth rocks do, it most likely has an iron core. And it does have a magnetic field. And the outer surface is the crust, and beneath that crust layer there is a lithosphere, so very similar to Earth. And volcanic eruptions have actually occurred on the moon to demonstrate that it has that same mantle material that Earth does. So when you look at the moon, the most visible aspects that tell you that there were volcanic eruptions are those dark spots. Those dark spots are called maria. And maria are from volcanic eruptions and lava flows that settled on the surface of the moon and left behind these low spots because the lava material settled and cooled and wound up being lower than the rest of the moon's surface. And they appear darker. And they're also darker because they're made of a type of volcanic rock that's called basalt, which is a mafic rock. The dark spots are called mare. Mare is the Latin term for sea, so that's where they got that name from. They're not actually oceans, they're just ancient lava flows. On the moon, the sky always appears black, and that's because the moon has a very thin atmosphere, and this prevents weather from occurring. The moon does not have any forces like Earth does in terms of air moving, wind blowing, water falling. So there's no weathering, there's no erosion, there's no day-to-day change in weather. So on the side of the moon that's facing the sun, the temperature can get up to 270 degrees Fahrenheit. On the opposite side, the side that's not facing the sun, it gets as cold as negative 243 degrees Fahrenheit. There is evidence that water exists on the moon. Now, it's not going to be in the blue oceans that we see on Earth. It's actually kept either in small, tiny droplets that evaporate from the moon's surface or bound to rocks and minerals. And when we bring back moon rocks and we analyze them, you can see evidence of water in the composition of those minerals and rocks. So don't be deceived. It's not saying that there's water on the moon. There's evidence of water on the moon. And that evidence, that water could have been brought there by meteorites. It could be brought there by ice forming at different parts of the poles when they don't face the sun. There's lots of reasons why that might exist. The moon's surface is iconically recognized as having many craters. Why does it have craters? Well, because it constantly gets hit by asteroids and meteors. Those never get wiped clean. When that happens to the Earth has the process of weathering and erosion that kind of erase over time anything that happens on the surface of the Earth. The moon does not have that process. So anything that's done on the moon stays on the moon. And when the astronauts first walked on the moon, they left behind footprints and tire marks and evidence of their landing. Those are still there. They're unchanged. This is a footprint from Neil Armstrong from 1969. That footprint is still there on the moon, and it will never change because there's no forces to change it. Now, speaking of astronauts, it was Neil Armstrong who first walked on the moon in 1969. NASA had launched 10 missions before that Apollo 11 mission, and much of the gear and equipment that they used to get there is still there. So there's a flag that's planted on the moon, American flag. There's a bunch of equipment. There's a lunar rover. There's a bunch of modules that they used. They're all still there because we couldn't bring them back. So it's just kind of a museum of the Apollo mission. Now, when we look at the moon, we always see the same side. We call that the near side of the moon because we can only see half of the moon at any one time. Because of that, the other side, which we call the far side, we never see from Earth. We'll never see the far side of the moon. So you're always looking at the same side of the moon. And that's been the case for as long as we can remember. The moon has always looked the same. Just recently, we've been able to send out orbiting satellites. And orbiting satellites have taken pictures and they have revealed to us what the other side of the moon looks like. So here's a video of what that other side looks like. So now we're seeing the far side of the moon, which we never see. And this is back to the near side of the moon, the side that we always see. So we always see the same side of the moon at any time. We see different portions of it through the month, and we call those phases. Just a little bit more about the moon. Its orbit around the Earth is not in a flat plane. It's a tilt, 5 degrees, and that tilt changes. It kind of wobbles back and forth. Sometimes it's up 5 degrees, sometimes it's down 5 degrees. So no matter what, the moon is never in the same plane every month. And that's why we may have full moons and new moons every month, but we only have a couple of lunar and solar eclipses every year. So the motion of the moon is very unique. One revolution is 27.3 days. So that's one trip around the Earth. But one moon rotation is also 27.3 days. So the rate of revolution and the rate of rotation on the moon are exactly the same. And that's why we always see the same side of the moon. And this is really hard to communicate. So I'm going to show it to you in 3 different videos. So take a look at this. If the moon didn't rotate, we would still see both sides of the moon. So as the moon revolves in this movie, you can see the red side. The moon's never red. That's not an accurate description. You can see the red side and the bright side, the white side. Let's watch that again. Okay? So if the moon doesn't rotate, you can see both sides. And I just finished explaining that we never see both sides. We only see one side for the entire year. So that being said, let's take a look at what happens if the moon did rotate. Well, now the moon's rotating, and it's rotating pretty fast. So we know, again, that this has to be wrong, because we don't see both sides of the moon as it revolves around Earth. We're only seeing one side. So how can we only see one side of the moon as it revolves and rotates? Well, here's the only way that that will work. The moon is going to rotate and revolve at the same time. So that red side of the moon is always facing the Earth. The moon is revolving as it goes around its orbit, but it's also rotating. And because it's rotating at the same exact speed at which it revolves, it always shows the same side towards the Earth. It's complicated. It's hard to believe, but that's the only way that this can work. Maybe the moon rotated and revolved faster before, and the Earth, because of gravity, slowed it down. Who knows? But we do see the same side of the moon at all times. So because we see the same side of the moon at all times, we don't always see the same amount of it. And when we see different portions, we refer to those as phases of the moon. Here are all the moon phases for 2017. There's a couple of things going on in this video. Here you have the moon going around the Earth, so you see its position. This is where we started, so you can see where it is in its orbit. Here you have how the moon's tilt changes because of the up and down movement of its orbit. Its orbit's not in a flat plane. It kind of wobbles back and forth as it goes around Earth. And as you watch it here, you can see the slow reveal over time of that shadow. And it's really not a shadow as much as it's just the portion of the moon that's being viewed by the Earth or visible to the Earth. So these are all of the phases that go on in 2017. Just roughly keeping in mind that every time, this is not perfectly accurate, but it's pretty close. Every time the moon makes one trip around the Earth, that's about 1 month. You can see over here this little moon as it pings back and forth between the cycle of moon phases. The cycle of moon phases kind of always falls somewhere between 29 and 30 days. So that's basically how long a month is on the calendar. So that's why these are all kind of synced up with. Now, if I wanted to recreate how phases work, I could do that. I could take a styrofoam ball, a fixed light source that acts as my sun, and the viewer, so you watching the video, are viewing the moon from Earth. So right now I'm looking at the moon at night as the moon goes through its orbit around the Earth. And if I watch that happen, I can see that changing phase as the moon moves around the Earth. Different portions are illuminated because of its positioning relative to the Earth and relative to the sun. The sun is always fixed, the moon is always revolving, and the Earth is also rotating. So those three interactions are what causes the phases of the moon. So when we talk about how the moon travels around the Earth and when we can see certain phases, it has a lot to do with predictable motion. So when the moon moves around the Earth, we always start our cycle here, when the moon is in the same place as the sun. In that position, we would see what's called a new moon. The moon would be out in the sky at night, but because we can't see the side that's being lit up by the sun, we don't see anything. In the next cycle, we see a little bit of the moon, and we call this the waxing crescent. If it's bright on the right side, it's a waxing phase. So this is coming out of a new moon, seeing a little bit more of the moon. That's our waxing crescent. Next, we're at our first quarter. Now, the reason it's called the first quarter is because every quarter of the moon cycle is a major phase. So the new moon was a major phase, first quarter, then we'll come here to full moon, and here to third quarter, or last quarter, and we'll be back at a new moon. So that's one cycle. This happens at the beginning of the cycle. This happens about 1 week in. So the first quarter is the first quarter of a set of moon phases. After the first quarter, there's the waxing gibbous, and once again, just the waxing phase means it's brighter on the right. All right, and we see 3/4 of the moon. After the waxing gibbous comes the full moon, where we see the entire near side of the moon illuminated. The entire 50% is shown to Earth. After that, we see the waning gibbous. The waning gibbous now is the opposite of the waxing gibbous. It's brighter on the left and darker on the right, so that's how I know I'm waning. After the waning gibbous is the third quarter, and the third quarter is opposite to the first quarter, brighter on the left. And then finally, the last phase before we get back to the beginning is a waning crescent. And a waning crescent is the little bit of brightness is on the left, and we're one phase before getting back to where we don't see anything. And that's a full cycle of moon phase. So the moon will cycle through these moon phases based on its revolution around the Earth and its positioning relative to the Earth and the sun. There's a lot here that we need to go over in more detail, and we will do that in class. Thanks for watching.